let's say if we have a complex number, z is equal to 3 plus 4i. And we want to convert it into this form, polar form. So if I have r times cosine of theta plus I sine theta, how do I do this? The first thing you want to do is you want to graph this complex number out. So let me graph it out. Now 3 plus 4i is going to be located somewhere here. So this point right over here is 3 plus 4i. That's going to be where our complex number is located. Now, right, in order to graph complex numbers, you need the complex plane, where, the x-axis is our real axis, and then our imaginary axis is the y-axis, right? So notice how this right over here represents the real part of this point, right? This point right over here, the real part of 3 plus 4i is just the 3 part, right? So it's going to be this length right over here, right? This is our real part. Now our imaginary part, that's like a y value, right? So if I draw an altitude downwards, it's going to create a right angle, and it's going to have the length of 4, because 4i, right? So this 4 right over here represents the value of our complex number. So, the first step when you're doing this type of problem is you want to visualize it. So you're going to just draw out our complex number, and you're just going to create a right triangle where the x value is here and the y value of, or in this case, our imaginary part of our point is going to be this length right over here. Now, in order to convert from this a plus bi to polar form, you need to know two things. You need to know what theta is, and you need to know what r is. So let me tell you what both of these mean. R represents the magnitude of our complex number. So how far away is our complex number from 0, right? So how far away is this complex number from 0? And we denote this length with r. Theta represents the angle that this complex number creates with the positive x-axis. So the positive x-axis, right? This right over here represents the positive x-axis, right? So it's going to be this angle that this r length creates with the positive x-axis. This is going to create some sort of angle theta. So in order to convert from this form to this form, you need to know what r is and you need to know what theta is. Now r, you can get this easily because notice how this is a right triangle and we have two sides of our right triangle. So we can get the third side via Pythagorean theorem. And this is just going to be a classic 3, 4, 5 right triangle. So r is going to be equal to 5. Now to find the angle, we can use inverse trig functions. So notice how we have a side opposite this angle and we have a side adjacent this angle. So normally we can say that tangent of theta is going to be equal to 4 over 3. And to get theta, to get this angle, what we can do is just take the inverse, and then we get that tan inverse of 4 over 3 is equal to theta. And this is going to give me my angle. Okay, so if I have my calculator right over here, all right, so tan inverse of 3 over 4, and that is going to, oh no, tan inverse of 4 over 3. Almost messed up there. And this is going to give me 0.93. And by the way, this is in radians, okay? So all the angle calculations I'm going to be doing is in radians, not degrees. If you want to change it, to degrees, you can just click this button and then, enter the prompt, and then you'll get that this is about 53 degrees. But, just for the sake of consistency, I'm just going to do these problems in radians, okay? This is about 0.93 radians. All right, that's what theta is equal to. Now that we know what r is equal to and what theta is equal to, we can substitute it back into our equation. So we're going to get that z is equal to 5 times cosine of theta, which is 0.93. And then it's going to be plus I sine of theta, which is 0.93, right? And then close parentheses, and there we go. That is how you do these types of problems. Just got to find out the magnitude of a complex number and the angle that it creates with the positive x-axis. So negative 5 plus 13i is going to be located somewhere over here, right? Because our real part in this case is negative 5. So if we go negative 5 directions here, right, this is going to be the x value of my point, right? And if I go 13 units up, well, this represents kind of the imaginary part of my point, right? So hence why we have -5 plus 13i, which is this point right over here. Notice how we've created a right triangle, right? So what we want to do, the two things we want to find out is, remember, we want to find out the distance the point is away from the origin, right? So this distance right over here, the distance it's away from the origin. And we also want to find out the angle that it creates with the positive x-axis. So if we have this right over here representing sort of the magnitude of a complex number, well, what angle does it make with the positive x-axis? Positive x-axis, remember, it's this part. So it's going to be this angle right over here. How can we find this angle? So first, I'm just going to find the radius, all right? So first, I'm just going to find out my r value, because that's the easiest to do. You just do the Pythagorean theorem, right? So a squared plus b squared is equal to c, in this case, r squared. This is 169 plus 25, 194. And, doing the math, you get r is equal to the square root of 194. Let me see if I can simplify this. Okay, so doing the math, this is 25 and this is 169. So you add them together, you get 194, and you take square root of both sides. So you just get the square root of 194. And I'm pretty sure this can't be simplified any further, but correct me if I'm wrong. Anyways, so now we know r is equal to the square root of 194. So let me just circle that real quick. Now, how do we find this angle right over here? Well, this part is very tricky, okay? So this part is very, very tricky. So I want y'all to pay attention. So look, this angle right over here, you can think about it as the angle for my triangle. So this right over here is the angle for my right triangle that I've created. Notice how this angle right over here plus theta gives me 180 degrees, right? Because right over here we have a straight line, right, which is the x-axis. And notice how these two angles added up gives me 180 degrees, right, which is this angle right over here, right, 180 degrees. So if I want to solve for theta, I'm going to get 180 minus x. But the thing is that it's actually not so simple. It's actually not so simple, and I'm going to show you why. So I'm just going to use the same method as I did before. So I'm going to get, if I know that tangent of my angle, right, tangent of x, so tangent of my angle in the right triangle, we know that's equal to 13 over -5, right? So if I take inverse tangent of both sides, I get that my angle is going to be equal to inverse tan of -13 over 5. So if we plug this into my calculator, inverse tan of -13 over 5, I'm going to get about -1.2 radians. Wait, but this doesn't make any sense. -1.2 radians is right over here. Wait, hold on. Wait, so we got x is equal to -1.2 radians. What? No, this can't be true. What? -1.2 radians is right over here, right? This is -1.2 radians. Right, because when you create a negative angle, you go clockwise, right? Remember, a lot of this stuff is very similar to what you've learned from the unit circle, right? This process where you create this right triangle, you draw this altitude down. In fact, some people, what they do is they imagine, there's like a circle, right? And this represents the radius of the circle, which is why, it's called r. But basically, right, you can imagine -1.2 radians as, if I, maybe this will help. So if I convert this into degrees, right? This is about -68 degrees. This is about -68 degrees. Meaning that, this angle is going to go clockwise, right? This angle is going to go clockwise. So it doesn't actually represent this angle x that we're looking for. So how can we, solve for theta if we're not even given our angle when we do our inverse tangent, right? Why does it give me another answer? So think about it like this. So tangent of theta represents sine of theta over cosine of theta. Tangent's equal to sine over cosine, right? Now, you can think about sine of theta, right? We know that sine of theta is equal to our y value. And we know that cosine of theta is equal to our x value, right? So you can think about sine over cosine as our change in y over our change in x. In other words, tangent is equal to the slope of our line. So right over here, right, in our diagram, tangent of our angle is going to represent the slope of our line. Okay, this is equal to the slope of our line. Now notice how there's two answers, right? If we want the slope of our line to be equal to 1, well, we have two answers, right? We can have, this can be one solution. This can be one solution right over here where we create this angle. Or we can have another solution, where we create this angle, right? Where we create this angle in blue. And this is also another solution to it. However, the thing is, when I take inverse tangent on both sides, the thing about inverse tangent is that it's restricted to a specific domain. And this is restricted from negative pi over 2, comma pi over 2. I will make a video covering this soon. But basically, notice how this angle right over here is over pi over 2, right? Because pi over 2, let me just draw this out here. So pi over 2 radians is this, and then negative pi over 2 radians is this, right? In other words, tan inverse gives me answers only located in the first and the fourth quadrant. So this is why oftentimes when you're dealing with inverse tangent, if you have any answers that are in the second and the fourth quadrant, it's probably going to give you a different value, right? Notice how, right, this angle, the angle that I'm drawn in red, right? This angle right over here is over pi over 2, right? It's not in this domain, right? This angle is over pi over 2, so that means that my angle is not in this domain, which is why if I actually take tan inverse of both sides, it will actually give me this angle right over here, this blue angle. This angle right over here is in between. It's in between pi over 2 and negative pi over 2, meaning that this angle is inside the domain of inverse tangent. This is kind of why when you're dealing with these types of problems, it's very tricky, because oftentimes when you plug in inverse tangent into your calculator, it only gives you one solution, because remember, inverse tangent is defined from, in the first and the fourth quadrant. But the triangle I've created here, this angle is in the third quadrant, meaning that this angle right over here is not in the domain. It's not in the domain of inverse tangent. So it's actually going to spit out a different answer. But the thing is that this angle right over here, let me denote with the blue, right? And you're trying to find this angle right over here, right? Now you know that this whole thing, this big angle right over here has to add up to 180 degrees or pi radians. So actually what you're going to do is you're just going to take this answer that the calculator gives you, and you're going to add 180 degrees, or in this case, pi radians. Okay. Oh, now that we got the radius and now that we got our angle, we can just plug it into our thing. So we have z is equal to, so r is going to be, we said it was the square root of 194 times cosine of 1.9 plus I sine of 1.9.